Algebra 2, Section 1, 2. Let's start by talking about the three words simplify, evaluate, and solve. What's the difference? Okay. Well, the first two are similar. Simplify and evaluate are similar. The only difference would be is that simplify truly just means that word, simplify. In a math sense, that can mean combine like terms if there are parentheses that can be removed by multiplying. Many examples that can occur, and we'll look at some of that in a little while. Evaluate, on the other hand, basically means simplify after you've plugged in some values. Okay, so a lot of times the problem that will be given in an evaluate problem, there isn't a lot of simplifying that can be done. Sometimes there is, but a lot of times there's not. There isn't a lot of simplifying that can be done, except for the fact that they said, okay, x equals this and y equals this, and you can plug those in, and then the task becomes simplify. And the last word is solve, and this is the reason that I'm bringing it up, is because you hear a lot of sloppy language. As a teacher, I can hear a lot of sloppy language from students, and I can even get a little bit sloppy myself with the word. And they say, well, so you solve it out or whatever, and when you're really not solving at all. There's a very big difference between simplifying and solving. Simplify is something you do to an expression that doesn't have an equal sign in it, and solving is something you do to an equation that has an equal sign and two equal parts on both sides. Okay. So we'll take a look at simplify and evaluate today, and we'll save solve for another day. Okay. Now, let's look at a couple of examples. This says evaluate. Okay, so the second word out of those three words that I was just talking about is evaluate, and that does mean that what we should do is plug -2 in for x. Notice that x is in two places here, and plug 5 in for y. Now there is work to be shown here. We expect to see work. I personally am not crazy with work, needing students to show work, but there is definitely work to be shown here. So please do. You're showing us you know what you're doing in plugging things in by showing us that work. If you just produced an answer here, that's pretty suspect. Okay. So now I want to execute using my orders of operation to simplify this, right? Evaluate means plug it in and simplify. So I've plugged it in, now I need to simplify. And do you know that this is multiplication? By the way, some people might not use parentheses here, but rather a times dot. I hope you are past using the times symbol, right? The X for times. Don't do that. We're way beyond that. If you had that habit going into Algebra 1, you should have dropped it by then. But parentheses means to multiply, or you could put the times dot here. I think that would be fine. This is a subtraction symbol, right? So we can go ahead and do this multiplication and the multiplication of these three numbers because they're separated by this minus sign. It's clearly here a subtraction sign. Now, you may have heard the orders of operation expressed as PEMDAS, right? Just to say the word as it sounds. Maybe it's please excuse my dear Aunt Sally. I prefer push Eddie Murphy down a staircase. And if you like Eddie Murphy, then maybe you pick a different person with an EM initials, so push Elon Musk down a staircase. Whatever. The P stands for parentheses. We don't have any. The E stands for exponents. We don't have any. The M and D are together, multiplication and division, and they come next. And that's what we're going to do here. 7 times -2 is -14. You're going to multiply -3 by 2. Actually, I shouldn't say it like that, though. It's going to be minus 3 times -2 times 5 would be 30, right? So there's a negative, so that means minus negative. Now, do you do what I do? When I hear minus negative, I just change it to plus. I just kind of go minus negative. And again, that's going to be 30. So -14 plus 30 then is 16. And 2 lines of work, like I said, I'm not crazy for you showing a whole bunch of work, but I think 2 lines would totally be appropriate here. Now they're a little bit crazier for work because they had 3. And then here again, there's another evaluate problem, and they tell us that K is 6. So we're plugging 6 in here and here. And this is 6 minus 18 squared minus 4 times 6 then. And now we do want to simplify what's in parentheses first, right? Please excuse my dear Aunt Sally, or push Eddie Murphy down the staircase. 6 minus 18 is -12. And again, because this minus sign is here, you're totally fine to go ahead and multiply the 4 and the 6 to get 24, right? Because we're not approaching the subtraction that's got to happen last, okay? Now, again, I said a minute ago, multiplication and division are on the same plane. It's not that multiplication supersedes division. Same thing with addition and subtraction. They're together, right? And you say, well, what happens when I have, a multiplication and a division? It's the last two operations I need to do. In that case, you just do left to right. That didn't happen here, but I just wanted, it could come up. All right, now, negative 12 squared, that's positive 144. Confirm that. Negative 12 squared in parentheses like that means negative 12 times negative 12. That's going to be positive 144. And we're subtracting 24 from that, so that's going to give us a 120. Okay, back to our little notes here. The word term, I want to talk about that for a second. I'm going to give you several examples. A term can be something as simple as 3, right? Any number is a term. It could be something as simple as a variable like x or n or xn or abc, okay? It is basically a combination of numbers and variables. So 6, x, y, z would be considered a term, okay? And I guess you could throw powers in there too. What it doesn't include is a plus or a minus sign. So as soon as I say something like 5x squared minus 3x, that's actually two terms. 5x squared is the quadratic term, and negative 3x would be the linear term. We'll talk about that stuff more later, but the point is that those are two terms, okay? And that's what a term is. In this case, again, this expression has two terms. Coefficient, that may be a word that you recognize. That just means the number that's in front in an expression like this. So 5x squared, its coefficient is 5. Negative 3x, the coefficient of that one is negative 3. Up here, the coefficient was 6. These are words that you would read about if you would look into your textbook. Okay, let's do another example. It says simplify by combining like terms. Simplify, again, as we talked about it from the beginning, means simplify, right? I don't have a simpler word for simplify than to just simplify. We're going to try to make this look as simple as possible. And you may remember the distributive property. If you've got a 7 out front of something like this, you're going to want to multiply that 7 into all of the terms inside of the parentheses. So 2h minus 3k, that stays. And then 7 times 2 is 14. So 7 times 2h would be 14h. And then 7 times negative 3k would be negative 21k. Okay? Now let me show you something. Look at the work that they put out for this. That's kind of ridiculous. I said earlier that I'm not crazy when it comes to work, and here's what I mean. What they're trying to do is they're bending over backwards using the commutative property to move things around, and then to show you that this actually is the distributive property, kind of in reverse of the way you're used to the distributive property. I don't think any of this is necessary. That work that I just showed is necessary. And now what I strongly think you should do is treat them like objects. If you have 2h and elsewhere you're going to add 14h, now you're going to have 16h. Treat them like, markers or pens or whatever. You have 2 of something, you add 14 more, now you have 16 of that something. Don't fall into the trap of thinking that it's squared though, right? That's when you're multiplying variables by themselves, right? It's not 16h squared. You have 2 h's, you're adding 14 h's, now you have 16 h's. If you have negative 3k and you subtract 21 more k from it, this is like you're going in debt, that's going to be negative 24k. So the answer here is 16h minus 24k. All right, and then just one more little explanation and one more example and we'll be done. The explanation is about absolute value. If you have forgotten absolute value, you might want to consult your textbook. I think it would always be a good idea to read the section either before watching a lesson or even after the lesson, but before attempting the homework, to just peruse the examples there. Absolute value is defined as being the distance from 0 to the number on a number line. Okay, so take negative 17. Well, negative 17 is to the left of 0 on the number line, but the distance is always positive. So that distance is 17. The absolute value is always the distance, and that means it's a positive number. If it's on the positive side, on the right side of 0 on a number line, well, then it's just going to be that number. So when you realize that, then the rule quickly becomes just take away any negative signs. If it's negative 17, well, then it's just 17. Just wipe away the negative. If it's positive 3, well, then it's still positive 3 because there was no negative. And there's a danger in that, because make sure that if you're going to do that, make sure that you don't wipe away the operation subtraction. Here's what I'm talking about. 3 minus 9 is negative 6. You don't just take the negative, this minus sign away and make it positive. That's going to be wrong. What you need to do is the work that's inside here, 3 minus 9 is negative 6. It's really asking us to take the absolute value of negative 6, which would be 6. You see, if I just change minus to plus, 3 plus 9 is 12. The absolute value is 12. You're going to get the wrong answer. 6 is correct. Here's something different, but also I wanted to talk about it. 2, again, the parentheses here with no operation would suggest multiplication. 2 times negative 4 would be negative 8. And then the absolute value is going to change that to 8. Okay? And then finally then, I guess that's it. I thought we'd do one more. This one's kind of a weird one, so we'll stop there. Thanks for tuning in.